Hello. Hey, everyone. Thanks for joining. Everyone excited for FHIRcast? Nice. Thank you very much for joining. This is Isaac Vedder. He wanted me to introduce him as some guy at Epic. And the talk is about from real-world problems to production at scale, FHIRcast. Take it away.
Thanks, Ward. Everybody hear me okay? Yeah. Okay. Gino, love the enthusiasm. Thank you. Nice carry through from this morning. That was great. Okay, yeah, so thanks, Ward. Isaac Vedder. I work on tools and standards that help developers build apps. And over the next 30 minutes or so, I want to tell you about one of those standards, FHIRcast. I also want to take some time to talk about some of the lessons that I've learned about creating interoperability standards. So first, I'm going to describe the problem that FHIRcast solves by explaining some history. Also explore why I think the time was right for creating a new standard in this area, and then give you a technical overview, a little bit of a deep dive into how FHIRcast works. Talk about the current state of the project, including some numbers that I have access to around initial adoption of FHIRcast, and then a little bit about what's next. Within the spec authoring community, it can sometimes feel like the only route to adoption is through government encouragement. That's why I think it's notable that FHIRcast, although led by a few significant implementers, is starting to see some global adoption. That's without carrots or sticks or perhaps even awareness for many regulators. I don't know, present company excluded. And so I'm going to selfishly use this session as an opportunity to kind of reflect and share some of the lessons learned around creating a new interoperability standard. And FHIRcast is far from perfect. I'd love to talk to you maybe one-on-one on some of the ways in which that's true. But my intent and goal is to kind of humbly share some of those lessons that I've learned. Okay, so FHIRcast solves a problem known as context synchronization. How many people know what that means? Okay, so that's why I'm giving a brief kind of primer. I know we've got some real experts in the room, and so bear with me. So context synchronization is kind of a complex problem to describe verbally and a really easy problem to understand visually. So let's imagine I'm a clinician. I'm working in Jason's chart within the EHR, and I need to reference some additional information about Jason. Maybe let's say in the HIE's web portal, for example. So I open up the second application, and I compare Jason's chart, information in Jason's chart against information from that HIE portal. Maybe I look at the problem list in both, right? And then, I continue on with my workflow. I move along to the next patient, opening up Jessica's chart. And then this is a bad thing, right? So we've got Jessica and Jason's information being displayed to the clinician on the same screen at the same time. Kind of introduces some mental load, introduces likelihood, possibility of confusion. It's generally kind of considered a patient safety risk. So what I want to happen as a clinician, what I want to have happen is for that second application to kind of automatically switch context to show me Jessica's information on both screens. And then when I switch back to Jason's chart, to show me just information about Jason. So, and back and forth. So how do we make that happen? So that is context synchronization. Context synchronization enables disparate apps to show the same content to the same user at the same time. And I actually started working with Epic's functionality that enabled this type of feature kind of in the mid-2015s or so. And that kind of was within both visually integrating applications within the third-party applications within the EHR, as well as synchronizing context. And at that point, context synchronization was actually really, really widely used in healthcare, especially within the imaging space, as radiologists are demanding users. And at that time, we were actually seeing less and less support for standards in favor of simpler, cheaper, and proprietary mechanisms. So I actually just want to walk you through a few of what those mechanisms looked like about a decade ago. So a really common approach was integrating two desktop applications by passing information between them over just a command line shell. So you could see maybe something like this. For example, my EHR might kind of log in a user, also provide a specific patient's MRN as part of opening up an external desktop application. And then those two applications would kind of could remain in sync through the exchange of command shell parameters. This is really nice and simple and definitely easy to troubleshoot. The note that this method is kind of limited to desktop applications, limited to the same machine, and pretty suboptimal probably from a security perspective, right? So another really common method was actually Microsoft's component object model, by which one developer's DLL could interact with procedures in another developer's DLL. So super powerful, limited to Windows, desktop apps, and also clear, security ramifications. A third context synchronization method was actually file system polling, and we still see this today. That's kind of two or more applications that are like reading a shared file system. So when, let's say, for example, the EHR opens a new patient's chart, it writes a small file to a specific folder. Then that desktop application is watching that folder and reads that file to know what patient's chart it should open, what patient's information should be shown to the user at that time. So there's, if you look at all of those, those are state of the art. And there's kind of a few obvious problems with them, right? As the larger IT industry kind of continues a shift at that time from desktop applications to web applications, these integration methods generally don't support web apps. And then over time, also those types of simple yet proprietary context synchronization methods multiplied. So we'd see every robust enterprise health IT application really to interoperate really needed to support half a dozen of these different methods. Every vendor had their own kind of spec, and they were all slightly different. And so that type of kind of duplication of functionality, I think really, what I began to observe that the effort and the opportunity cost for me to maintain every single one of those different specs and implementing comparable functionality meant that I didn't have time, our dev team didn't have time to actually develop new features that our customers were asking for, to actually innovate with on top of that integration layer. Further, this was about 2014 or so, we started to see smart apps happen. And the best user experience for integrating a smart app into a clinician's workflow is actually to embed that web app into an iframe or some other UI visual container within the EHR. And that's how demonstration apps at the time, of which I'm doing kind of a shout out there to the pediatric growth chart from Boston Children's Hospital. It's a beautiful growth chart. That's how a lot of those demonstration apps at the time were presented. However, it seemed obvious to me that as smart apps really matured and continued to be developed, that they need more of their own screen real estate and kind of functionality, so that requiring them to fit within this iframe on that single monitor ultimately wasn't sustainable over the long term. And note that as part of that Smart EHR launch, there is some contextual information is provided to the application upon launch. So for example, here we've got the patient. Yeah, so patient encounter imaging study, for example. But then notably, once that application has been launched, it isn't told about any context changes again. It's only upon launch that contextual information is synced. Okay, and so here's all of the things that are wrong kind of with the current state of things as of 2015 or so, but I want to call your attention to 2 points. So one is that there's a bunch of these vendors that supported all of these disparate context sync methods. That meant that they each kind of recognized the problem and had a real need, probably a business need, a customer-driven need to solve that problem. So they shared a problem in common that they wanted to solve. That's notable. 2, there's overlap in this Venn diagram. There's actually overlap there. And what I mean by that overlap is that all of these vendors, all these software applications shared some kind of capability to announce and change clinical context in reaction to requests from external applications. So that basic capability of like, hey, I'm going to open a new patient now because this other application told me to, existed within the industry, across a number of applications in common. And so actually, I think that some of those 2 factors meant that there was really kind of almost optimal conditions for defining a new standard, for having parts of the industry coalesce around a new standard. So by standardizing that kind of widely shared and existing capabilities, we could promise implementers a reduction in maintenance for all those disparate proprietary specs, as well as like a new feature, this improved support for web applications. And there also wasn't one type of actor that benefited more than another type of actor as part of introducing a new standard in this area. So this is, I want to make the point that I think new standards, new implementation guides, really are most successful when they don't try to replace a production capability without also providing a really significant functional advantage. And that can be something that's easy to lose sight of when we say hey, that V2 interface, that should be FHIR. But I think that every time that we think that as a community, we want to make sure that by moving to FHIR, there's some type of new significant functional advantage. I'd like to think of it as a paradigm shift. What's the new paradigm that moving to FHIR will benefit the community, benefit the integration by doing that work? Okay, so FHIRcast is that new standard that we worked on, that we initially created, intended to be modern, simple context synchronization. That's web and FHIR first, then extends the Smart on FHIR app launch to enable basic smart apps to make use of context synchronization. So I'm going to do a technical overview of how FHIRcast works. So starting with the Smart on FHIR application, which not every FHIRcast app needs to be a smart app, but the simplest story. But we've ensured that FHIRcast works really well with smart apps. As part of that standard smart launch flow, an app asks for FHIRcast-specific scopes. And in this case, so it's asking for authorization to receive the FHIRcast patient open scope to be notified when a patient's chart is open. Once granted, and in addition to that typical kind of smart contextual information, again, patient and encounter, the authorization server returns 2 FHIRcast-specific values alongside that access token, which enable the application to subscribe to the user session. So specifically, the app that makes a simple HTTP post to that hub URL value that it received as part of the smart launch. And then it uses the topic that it received as part of the smart launch as a unique session identifier. So let's see. So smart app gets launched, gets a couple of additional pieces of information, including a URL and this session ID and this unique identifier. And then it turns around and just makes a simple HTTP post to that URL and says, hey, I want to subscribe to this session. Here's the events that I want to be notified of when they happen within the user's workflow. Here's the events that I want permission to be able to send to other applications participating in the user session. And then that hub.topic is, again, the specific user, maybe on that same machine, and with a shared session of other applications. So that hub topic is that unique session identifier across those. And then finally, the hub, the application receives a WebSocket URL that the application can then connect to, such that once a workflow event occurs, like that patient chart open, the application receives an event notification through that WebSocket connection. So FHIRcast events, so I said that FHIRcast was FHIR first in addition to web first. So I think that web first is evidenced by the use of WebSockets, the use of HTTP, and by enabling smart apps, even single page applications, to participate within a FHIRcast context synchronization session. So I also said that FHIRcast is FHIR first, by which I mean that we use FHIR as the content model that's exchanged as part of that session. So in this case, the application received a patient open event, so which meant that in one of the other applications participating in this session, the clinician, the user, opened a patient's chart, newly opened a patient's chart. And so that smart app, through that website, through that existing WebSocket connection, receives a kind of a JSON object. There's a little bit of like FHIRcast specific header data that contains things like the timestamp, that session identifier again, what event occurred, and then also a patient FHIR resource. Also notably, FHIRcast is bidirectional. So that Smart on FHIR application can also request that contextual changes be made within that session, such that other applications participating in that session change their context to match mine. And that looks like this. A simple HTTP post, again, is how that application requests a context change. This context change is then broadcast to all of the subscribers, so including myself, the initial requester. Maybe one point here that's implied is that there's no limit to the number of applications that can participate in a FHIRcast session. A lot of times we think of this as just 2 applications, like there's the kind of clinical workflow system, for example, in EHR, and this smart app that got launched. But in practice, we see in, for example, the imaging space that there's often the radiology information system, a PAC system, as well as a dictation system, all participating within a FHIRcast session. There's also a lot of, I think, use cases that we haven't really even come across yet in terms of what are applications that can benefit from following along with a user's session, and how can they provide additional input and value. Okay, and we've been primarily talking about that patient open event because it's nice and understandable. I open this patient's chart. Everybody wants to hear about that. We actually, in the spec, define a syntax for defining FHIRcast events. So this is kind of just a basic pattern where we have a noun and a verb. A noun can be any FHIR resource. So patient is a FHIR resource, encounter is a FHIR resource, imaging study, diagnostic report, et cetera. And then our primary verbs are really open and close. Opened a patient's chart, closed a patient's chart. Opened that diagnostic report, closed it. And then kind of the frontier of FHIRcast is that we're looking at reusing that context sync integration to also exchange clinical findings within the context of a diagnostic report. So we've introduced a diagnostic report update event that I think is still in the process of maturing. That there's a lot of experimentation happening within the industry right now around. And then we've also been playing with this select event that I think we've even now marked as experimental in the base FHIRcast spec. And then the reason why we can say here's a general syntax, you can define any event you want, is because we also kind of critically, objectively evaluate the maturity of each event that's kind of introduced within the industry. We define a process by which events can be dreamed up, submitted, contributed, described, matured, tested, and eventually like moved even to a normative status within the FHIRcast specification. So our FHIRcast event library, also maybe if you're interested, this is all just totally stolen from the CDS hook spec, this maturity library. But I wrote it for that too, so. Okay, so the FHIRcast event library this is the current list of events that we actually define in the spec and have assigned a maturity model level to. So I think we see patient open and close are super common. Actually, you know what? I'm going to get to adoption numbers in a little bit, and I'm going to show you, at least from the data that I have access to, what some of the usage of these events are over the past 6 months in production environments. Okay, and then the final step is that smart app. You remember it got launched, turned around and subscribed to some events, it received an event, and then lastly, when maybe that smart application closes, it can unsubscribe from that user session. I think in practice, we're seeing that this doesn't always happen, but this is kind of how it's intended to work. Okay, so really when we started, we had some really specific FHIRcast design goals. So again, I talked about web first, talked about FHIR first. I think that those health IT kind of industry forces, I think are things that FHIRcast has benefited from. And this is maybe a non-obvious point, but some of those proprietary, disparate specs that I talked about at the beginning, they're simple. You know, like, oh, hey, here's a command line switch. You know, like, I'm passing you an MRN, or here's this like super simple little XML file that you can just pull from a file system and read. Like, they are not complicated. And that to a fault, perhaps. But I think that what we've seen previous context synchronization standards went really far towards the side of guaranteeing synchronization, even at the cost of performance and at the cost of dollars. And so one of our kind of design goals was to try to replicate that simplicity in a standard. And I'm not actually totally sure that we succeeded all the way there. But that's always been kind of one of my goals with FHIRcast, is to make it simple. And then lastly, I talked a little bit about that. Okay, so I wanted to talk a little bit about some adoption numbers. And I think that with FHIRcast, we really are just at the beginning. And I'll talk a little bit about about from the standards development perspective, the process that it's taken to get here, and then also try to draw some of the lessons that I've learned as part of that. Like right now, and this is all Epic data. I don't have access to anybody else's data. And so we're seeing kind of incredibly rapid growth of the use of FHIRcast within the Epic health system community. Really centered around a very small number of, relatively small number of applications, and for use cases that you wouldn't expect. Further, I think that as the community gets more experience, we might even see some of these numbers decrease, because these are ridiculously high numbers. And I think it's like folks are being really wordy with FHIRcast right now. That might be an opportunity for improvements within the spec, or at least within kind of implementation guidance. So, okay, so what does this mean? Okay, so I'm really, so I've got two FHIRcast events here are charted. So patient open, which we've been talking about a lot. Patient open is the most commonly used event right now within production environments. So in May 2024, so last month, we saw something like a little over 800 million FHIRcast events exchanged in production environments across just 186 Epic organizations, which is seems like a lot of events to me. But there's a lot of times that clinicians open a patient's chart. And then user logout is kind of an infrastructural event that's defined within the FHIRcast spec. That means, just what it says it means, right? That actually we saw really significant usage of as well. So something like, 570 or so million events, again in May. And then look at the rate of growth there. I think part of that is maybe specific to the Epic community as we roll out our web platform, that as organizations adopt that, that's actually that's when organizations begin using this functionality. So I put this on a little bit of a table. And I actually want to make a couple of points here. So just to orient you, so again, on, let's see, your left, we have the FHIRcast event, right? So patient open, close, et cetera. And then in the right column, we have the number of transactions across the Epic community in production for last month. So patient open, we already saw, that's giant. Patient close is, you think there would be an equal number of opens and closes, right? So I don't really know what happened there, honestly. I think maybe people unsubscribe or disconnect, or the clinician closes their EHR without closing patient's charts. Okay, and then similarly, we see kind of almost similar numbers to with encounter open. And then imaging study open. I thought imaging study open was going to be the primary use for FHIRcast, because we see context synchronization within radiology and within imaging use cases is so vitally important, because it speeds up, speeds up clinicians' user experience. It speeds up their workflows. It makes them more productive. And so I think the fact that the imaging study events aren't being used right now means that, at least from one implementer's perspective, from one implementer's data, we're not actually seeing FHIRcast being used all that much in production imaging environments yet. Rather, and I think these next two events kind of illustrate this, we're seeing user logout and user hibernate, again, are two kind of infrastructural events that are seeing really significant use. And I think that the use cases that these early initial adopters of FHIRcast, early initial at scale adopters of FHIRcast are more about kind of monitoring users' overall sessions and providing instead of synchronizing to imaging studies. So I think that this is going to change. I think as we will eventually see more and more imaging applications and imaging integrations, I think, begin to use FHIRcast. And I think, based upon how things are going, it might actually be that central FHIR resource that organizations kind of center their integrations around might actually end up being diagnostic report instead of imaging study. If you're interested in that kind of thing, come talk to me later or join the FHIRcast work group. Okay, so what's it actually taken what has it taken to get there so far? So I want to just humbly talk a little bit about the standards development processes that we've undertaken with FHIRcast as a illustration of some of the things that I've learned about FHIR and interoperability standards development over the last, 7, I guess, years or so. Well, since 2017. So this is just a calendar of FHIRcast ballots within HL7. I think the point here is there's a lot of them. So over the course of working on FHIRcast, so I think that some of the things that I've really taken to heart are that in order to make the best standard kind of solves a problem that is really a perfect problem. The more you can find a perfect problem for when you create a new implementation guide, the better off you're going to be. And in this case, what I mean by that is that there's already some existing functionality within the industry that solved this problem. There was already existing implementer need to solve this problem. A standard could solve this problem in the same way for multiple different types of implementers, and they would all benefit. There was kind of an increasingly urgent need in order to enable more web applications to use context synchronization functionality. As we saw the rise of like smart apps, as we predicted the rise of smart apps, like that was only going to get more and more urgent over time. So I think that that's an example of like a really kind of a problem that needs solving. I think this illustration is intended to just kind of show that, oh, holy crap, this takes a long time. And then over the course, I know that we've got some real professional like IG authors in here, but I feel like 740 ballot comments is, oh man, that just sounds exhausting, doesn't it? I don't know. Okay, and then a bunch of commits. Over the years, we've had 14 Connectathon tracks just for FHIRcast. And we've actually also had 7 distinct open source reference implementations from the community. Actually just went to like look and see where stuff was, because a lot of those have fallen into disuse. And just maybe like last week, like some late night last week, and I saw that Martin here, who I haven't interacted with in years, had just updated the FHIRcast JavaScript sandbox like within the last like 10 minutes. And I thought, oh man, that guy's awesome. And I want to kind of specifically point that out to make the point that there's really like no interoperability standard can be successful without forming a community around it. If you try to do things, if you run projects, standards projects that are too top down, or where innovation or movement can only happen from a centralized place, like you're not really gonna, you're limiting your ability to be successful. It's when people all over the world can feel invested and involved and make contributions, that's when you can see the greatest acceleration and the most success. I also wanted to make a point about kind of accessibility of standards projects, and I think that those sandboxes, I think, are a really good example of that. HL7 implementer division's work on the Foundry, I think, is an attempt to replicate and standardize that process of making sandboxes and making reference implementations of higher quality and more available across a broader range of HL7 FHIR standards. I think that has the potential to really be awesome. But sandboxes and open source implementations of a standard are what make it accessible to implementers. I think another thing that makes a standard accessible to implementers is actually like search engine optimization tactics. Like, do you have a good domain name? Do you have a logo? And we haven't done any of this stuff perfectly in FHIRcast, but this is some of the things that I've really kind of come to believe. Okay, I want to just kind of give a brief description of kind of where we are from a standards perspective and what's next. So we're in the process of finally publishing FHIRcast version STU3 sometime this summer. It's the version of FHIRcast that I think we're really at the point where all of our context synchronization functionality within FHIRcast is mature and is relatively stable and is beginning to see some early production adoption at scale. And my hope is that we can actually kind of take that part of the spec normative and lock it into place relatively soon, which means years. And then so the next phase of FHIRcast is that diagnostic report update type functionality. So this is the ability for applications that are participating in a FHIRcast session to share, to generate, share, and suggest to a clinician in real time a clinical finding. The kind of most, I don't know, maybe the easiest explained, or at least easiest understood to me at least, use case here is, as we've seen, like just image analysis algorithms over the last 10, 15 years get better and better and better and better. Like how do we operationalize those algorithms' ability to interact with imaging clinicians, with radiologists, with cardiologists, in terms of suggesting, clinical findings about images to that clinician within their workflow. So, and again, we've got some experts here that I defer to as well. But so, for example, like, what is the volume of this breast nodule based upon, that algorithm's analysis of images from an imaging study? Can that be fed into the radiologist's workflow as they are, creating authoring their diagnostic report, so that they can easily kind of accept that data or decline it? Yeah. And so I think that we've got a lot. So one, that's really neat and exciting functionality, and there's a problem there that I think we can solve, and there's an opportunity for a standard, and it benefits the radiologist most importantly, as well as kind of the different actors in play there. And I think we've still got a decent amount of work in order to get to the point where we can really, where we will see that type of that use case deployed at scale within FHIRcast, but that's really going to be increasingly the focus of the FHIRcast community, as well as kind of the HL7 standards development processes around FHIRcast. Okay, and that's it. So I think as part of the wrap up, we looked at some of the history of context synchronization. Thanks for bearing with me. I don't know, was that boring? What'd you guys think about that? Was that, okay. I know, yeah. The folks in the imaging space are like, whoa, yeah. I know, me too. And then over the last decade or so, we considered some of the industry shifts and needs that enabled a new context synchronization standard. Did a little bit of a technical overview of FHIRcast. And so what questions do you have?
Thanks, Isaac. That was awesome. I see hands going up already.
Yeah, Isaac, this is Victor from Singapore. Can I clarify, maybe you shed some light on one of the stacks that within the EPIC organization, there's a patient contest open about 800-some million events. So this kind of event broadcast to what are the participating systems?
Yeah, and I didn't...
Because I thought EPIC is pretty low as a hub, right? Broadcast the event to some other system.
Yeah, and I didn't break that down. I think that all it is that one of these transactions means that there was an external third-party system that subscribed and requested that an event be sent, and this data doesn't provide doesn't really explain why or what that external system did with the event. I think in theory it'll vary a lot what external systems do with those events. I'm specifically not. There's not really that many applications that are doing this. I think we're really just seeing, a dozen or so applications that are being deployed pretty widely that are using this technology, that are generating this traffic. It's just across many, many clinicians, across many, many hospitals and clinics. And I am not saying who those applications are because I didn't talk to them about it ahead of time.
Right now, we are trying to build when I look at FHIRcast, it seems to more address the digital image problem, right? But right now, I'm leading a project. We try to build a framework for the use case like EHR and app can talk to each other. And we are evaluate FHIRcast because we like the FHIRcast actually provide a bi-directional message, which is nice. However, we are not interested about the context change. At least the initial version, we might able to address later because we are not in the digital imaging.
Yeah.
We actually addressed a lot of use cases regarding to like e-consult and e-referral.
Yeah.
So those kinds so we want to like a bi-direction.
Yeah.
So there's a debate. Either use the, so we are more concerned about the content change. And I know you have balloting for 3.0, right?
Yeah.
But that is use case you mentioned is more like a diagnostic report change. We are actually more like encounters, those kind of stuff, right?
Yeah.
So there's a debate.
Yeah.
Say either use FHIRcast or FHIR subscription. But
I think
so
you
that's,
should
I want to hear your
You should
opinion
use
there.
FHIR subscriptions. That's my take. I think that like, so for the longest time we said, look, FHIRcast is just about context synchronization. And that's why we're creating this new like communication mechanism, this particular use of WebSockets. I think FHIR subscriptions technically has a channel of WebSockets. I don't think that's really been vetted out or used. Oh, and yeah, as well as webhooks, right? But I think that, man, I tried really hard to get our FHIRcast community to just, why aren't we using FHIR subscriptions for this? And the answer is because I think it's a lot of that diagnostic report update, that content sharing within FHIRcast really is specific to the imaging community. The imaging community has not, or is only now investing time and effort into the use of FHIR. So it's not like they've already got FHIR servers deployed, right? Which this type of a use case in FHIR subscriptions would require them to be. Rather, it's convenient for that community to, since they're already like in the process of deploying FHIRcast for context synchronization, to reuse those communication channels to also enable this really specific, this imaging use case. I would say for other use cases, we've got Lloyd in the back here too, which is defined some of these, the decision tree that talks about this type of stuff. I think for other types of use cases, you're definitely better off using more base FHIR functionality.
Yeah. Is it? We have 3 minutes left, so try to round it off. You can also sure later.
Okay, I will try to be short. Another big difference I noticed: the FHIR subscription is unidirectional. So it's, we really like the sort of the bi-direction from FHIRcast.
Yeah.
Thank you.
Hey, thank you, Isaac. Really nice presentation. And I can see the value of FHIRcast in terms of the smart applications. One of my question is, the numbers looks really high and just for a few months. My question is, was there any performance impact in terms of the user experience or clinician using the EHR? And as adoption grows with this, the numbers will just shoot up.
Yeah. I think that a lot of that is maybe architecture dependent. I think that I was not the person who architected Epic's implementation of FHIRcast. But I think it was done pretty well. But we actually have, my understanding is that we have seen some performance-related considerations come up, and have even worked with some of these third-party developers to be more selective about when they. This was about incoming actually, when they send incoming FHIRcast events. But yeah, and so my hope is that probably maybe this number stabilizes or even comes down a little bit. Like, I think we need to, as an industry, like we need to figure out when do you want these events? When do they provide value? How do you selectively subscribe? How do you make sure you're only listening to the sessions that you need to be listening to? I think all of that type of optimization phase is still ahead of us. Yes, Mark, what a great question.
Okay, we're at time. So if you have any more questions, find Isaac after.
Please.
He's here.
Here all
Thank
week.
you very much, Isaac.
Yeah, thank you guys.